So now we're going to get everything that we need to get for autonomous mode to be functioning up and running, and just as a general good first step, it's kind of hard to see the screen with the steering wheel on, so oftentimes you like take it off. So you just remove the nut in the center and pull it off, and then you can see the screen a lot easier. So let's put this back here and then put the nut back on so that way you don't lose it. Okay, so we're in the workspace, and so we're going to have a couple step process here. So the first thing we need to do is we need to get the LiDAR connected to the computer and outputting or publishing the point cloud. So the first thing we're going to do is we're going to run ROS launch, Velodyne, and then it'll tab complete point cloud, and then VLP, and then it should tab complete this point to VLP16_points.launch. And I'm going to background that. So now that's connected and running. Now we're going to ROS launch, point cloud to laser scan, and that'll tab complete as well. And then P2L, and that'll tab complete to P2L.launch. And we're going to background that. And so now we're going to get the APM autonomous mode nodes running. So the first one we're going to run is we're going to do ROS run APM_autonomous, and that'll tab complete. And so the first one we're going to do is vector_2_command, and then I'll tab complete. So what this is going to do is this is going to take the desired vector and it's going to convert it into commands for the throttle, steering, and brake. And I'm going to background that. And then the next one I'm going to run is also an APM autonomous, except it's the artificial potential field. So what this is going to do is this is going to use the laser scan coming from the point cloud, coming from the LiDAR, to develop a set of environmental forces which are going to affect our desired vector to steer us away from obstacles. And you can read more about that in the operations manual. So we're going to launch that off right now. So now it's time to run the odometry generation to generate our odometry, and we're going to run the local driver. So you're probably going to do those in two different tabs because they both output things. So here we'll do ROS run odom, and then cart odom, or sorry, gen odom.
Odom gen.
Odom gen. And we're just going to leave that one not backgrounded, and this will start generating the odometry. And so you can see we're at 0, 0, and now I'm going to Control-Shift-T and open up a new tab. And now I'm going to do ROS run, and I'm going to do APM autonomous, and then local driver node, and then this is where you're going to give it the text file. So we just called it test demo.text. Okay, so at this point we have the local driver, which is going to try and follow the points file that we generated before. You can see that it's showing no angle error right now because we haven't started. And that's our odometry data, also showing at 0, 0. So at this point we can switch back over to RQT, and if we hit the autonomous button, then we should begin to drive autonomously. And we're off. Right, so when we're running it autonomously, we always have someone with a remote control and their finger on the emergency stop switch, just in case the cart was doing anything erratic. And also be aware too that if it was to do something unexpected, that you have the large emergency stop button here that can be pressed at any time. Be aware though that if you press that you will have to restart the computer before the cart can be running again. So you can see what's happening here is as we're driving, our odometry information is degrading, and it's starting to lose the path. Because of that, we're relying on the object avoidance artificial potential field to steer us away from danger. So at this point, it most likely believes that the path that we're trying to head is in this direction, but it's avoiding the curb because it's in the way. So a way to get it back on path is to actually have a moving obstacle in the way and to push it in the direction that you want to go, although of course this is not ideal. What we recommended for you guys is to absolutely get better odometry and localization working, and that would include using a much better IMU. If the cart has a good path to follow, and it actually behaves very well.